Hi, in this video I'm going to show you a more advanced example of how to solve equations with algebraic fractions. Don't forget to subscribe if you are enjoying these videos and you're finding them helpful, because it really does help my channel to grow. So thank you very much for subscribing in advance. The first thing I'm going to do is to solve this using cross multiplication, and a quick reminder of how that works. So if I've got a over b plus c over d, that is equal to ad plus BC, so I cross multiply, over the two denominators multiplied, which is BD. Okay, so that's exactly where I'm going to start this question. I'm going to multiply across. So I get 5y plus 2 plus 6 2y plus 3 over 2y plus 3 over y plus 2 equal to 3. Okay, now obviously there's quite a bit of simplification needed here. So let's multiply out these brackets on the top. So first of all, I've got 5y plus 10 when I multiply out this bracket. And then I'm going to times everything in this bracket by 6. So I get 12y plus 18. On the bottom, I'm going to do what I quite like to call the smiley face method. Okay, so I get 2y squared, first of all, from the left eyebrow, plus 3y, plus 4y, plus 6 when I times everything out, equals to 3. Right, quite a bit of simplification needed here, and I'm probably going to need a bit more room. So I'm just going to take this part over to the next page and keep going with it. So let's simplify this top numerator first. So I've got 5y and 12y, which gives me 17y. I've got 10 plus 18, which is 28. On the bottom, I've got 2y squared plus 7y plus 6, and this is still all equal to 3. Now, remember what I said about dismantling. When I'm doing algebraic fractions, trying to solve them, I dismantle the fraction because I don't really want to work with fractions. So I'm going to times by the denominator here. So 17y plus 28 equal to 3, and multiply both sides by the denominator. The denominator basically comes up here and is times by this. It disappears on this side. So 2y squared plus 7y plus 6. That can now be multiplied out. So 17y plus 28 equals 6y squared plus 21y plus 18. And the thing is, when I'm solving a quadratic equation, I need to set it equal to 0. So I really need to bring these terms over here as well now. So I'm going to take away 17y first of all from both sides. So I get, still left over here, I've got 28. I've still got a 6y squared. 21y take away 17y is 4y. Okay, so plus 4y plus 18. And the next job I've got is to take away 28 to set it equal to 0. So 0 equals, take 28 off this side. So what I get is 6y squared plus 4y. 18 subtract 28 is negative 10. All right, so I am getting there, slowly but surely. Let's just take a screenshot of this now, because I need more room. Okay, this is what I need to solve now. This is my job. So let's keep going. Ooh, whoops, what's that? Let's keep going. So here we go. That's what I'm solving. I'm going to write it out again with the equal sign on the right-hand side, just to simplify things. So 6y squared plus 4y minus 10 equals 0. Now I'm going to introduce you to a little hack at this point. So I've got a common factor here of 2, and if I divide everything by 2, it's still going to be equal to 0, because obviously 0 divided by 2 is still 0. So I can actually do that. I'm well within my rights to divide everything by 2 and make life a bit easier for myself when it comes to factorizing. So I've got this, okay? Now, my next job is I want to try and factorize this, because that's the easiest way if I can. Otherwise, if I can't, I use the quadratic equation. Let's see if I can factorize it. I need to make a 3y squared, so it's got to be a 3y and a y. The product is going to be a negative. So I know that one of them is going to be positive, one of them is going to be negative, the two numbers that will go into these brackets eventually. I know that they need to multiply to give 5, so I know for sure they're going to be 5 and 1, because 5 is a prime number, so we've got two factors. And I also need to ensure that when I do the smiley face method of multiplying these two brackets out, I get 2y as a result. Okay, so I need to think quite carefully about where to place the 5 and the 1 and the positive and the negative. So let's have a think. If I put the 1 here, let's have a think. If I put the 1 here and the -5 there, let's see, I get -15 plus 1, I get -14y. It's not going to work. So there's a little bit of trial and error in thinking about this. Let's have a think. Would it be, it would be probably, I think it'd probably be +5, wouldn't it? And -1. And let's see why that works. We've got 3y squared, we've got -5. They're two things that we need to have coming out of this. And then we'd also get 5y subtract 3y, which would give us +2y. So that definitely works. I'm happy with that. Okay, so I'm happy. And now I need to think about the two values of y that would make this equal to 0. Now, either this bracket is equal to 0, so y minus 1 is equal to 0. In that case, y would have to be equal to 1. There's my first solution. Or this bracket would equal to 0. So 3y plus 5 would be equal to 0. Now, in this case, if I took away 5 from both sides, I would be left with 3y equal to -5. And then I can divide by 3 to solve the quadratic finally, which is y equals -5/3. So that's my other value, my other solution to y. So pretty long-winded there, but we did get there in the end. We relied on a method from prior knowledge of how to solve a quadratic by factorization. Okay, so the final answers, there we go, are y equals 1 and y equals -5/3. Okay, so quite a lot going on there, a lot of skills across multiplication, solving an algebraic fraction as an equation, and then finally the quadratic revision there. So I hope that's been helpful. I hope it's been nice and clear. Leave me some comments, like and share, subscribe, do all those things, help me out with my channel. Thank you very much for listening.